Hi friends, I am Ramya. Today my topic is on position time graph. Position time graph for an object in three different conditions. These are the three cases. In each case, how the graph will looks like under these conditions. I would like to explain it in this video. In the first case, the object is at rest, means the position of the object is not changing with the time, then we can say that it is at rest and it is stationary. And the object is in uniform motion. Uniform motion means velocity v is constant and acceleration is 0 because the particular vehicle is not picking is fast. Then we can say that acceleration is 0. Velocity is constant means, let us take an example. If the vehicle starts at time t is equal to 0, that is the initial position of that object, vehicle. After 1 hour, its velocity is or its speed is 200 kilometers per hour. And after 1 hour, the velocity is same, that is 200 kilometer per hour. And if we take another 1 hour, the same velocity, the vehicle going with same velocity, that is 200 kilometer per hour. In that case, we can say that velocity is constant, that is nothing but uniform motion. And in third case, the object is in uniformly accelerated motion. Here, in this case, the vehicle is not accelerating. It is not getting fast. And here, it is uniformly accelerated motion. Here velocity is changing and acceleration is constant because uniformly accelerated. In this case, I will give one example. The vehicle starts at 1 hour. The vehicle moves 200 kilometers, and in next 1 hour it travels 300 kilometers, and in next 1 hour it travels 400 kilometers. In all these three cases, the velocity is 200 kilometer per hour, and in second 1 hour the velocity is 300 kilometer per hour. And in third 1 hour, its velocity is 400 kilometer per hour per 1 hour. In this case, the velocity is changing 200 kilometer per hour, 300 kilometer per hour, 400 kilometer per hour. But what is the change in velocity? Change in velocity is nothing but acceleration. Change in velocity, here 100, here also 100, and in further case also, if we take 500 kilometers per hour for next 1 hour, that is also 100. In all these cases, the velocity is changing but uniformly accelerating. The acceleration is changing, the speed is, the vehicle is getting fast. For 1 hour 200, next 1 hour 300, next 1 hour 400 to reach its destination. In all these three cases, in order to reach the destination fastly, that vehicle gets accelerated. But what is the change in velocity? It is 100, 100, 100, which means that is uniformly accelerating. Uniformly accelerating. In that case, we can say that the object is in uniformly accelerated motion, but the change in velocity is uniform, that is acceleration is uniform. We can say that change in velocity is nothing but acceleration. Here velocity, the formula for velocity is displacement by time, and acceleration is change in velocity by time. Here the units for velocity is meter per second. and units for acceleration is meter per second square. And here in this video, I will explain these two conditions, the graphs for these two cases, and in next video, I will do graph for this condition. Here in next topic, that is graphs. Graphs for this first condition. When the object is stationary, in that case, if you see this graph, the graph will looks like this. Here object position is not changing. It is at x0 itself. It is not going x1 position, x2 position and etc. It is still in x0 position. The time passing at 1 second it is in x0, and at 5 seconds also it is at x0. Then we can say that the object under consideration is at rest, means its position is not changing. Its position is not changing with respect to time. Here the graph will looks like this. It represents like a straight line and which is parallel to the positive x-axis. This is x-axis and y-axis. Here on x-axis we are taking time. It is an independent variable and position is an dependent variable. The dependent variable we can take it on y-axis and independent variable we have to take it on x-axis. This position depends on time. That is why it is dependent variable. And this is the first case. The graph looks like this. In the first case, when object is stationary, and in second case, when the object is in uniform motion, the graph will looks like this. The graph will looks like this if the object is in uniform motion. In that case, velocity is constant, acceleration is 0. Here, when the object is in uniform motion, it covers equal distances, means in the first example, I already said that is 200 meter per second, 200 kilometer per hour or 200 meter per second. Both are same. 200 meter per second. For each hour, the velocity is constant, that is 200 meter per second, 200 kilometer per second, 200 kilometer per second, 200 kilometer per second. Then we can say that the velocity is constant, that is nothing but uniform motion. It covers equal distances in equal intervals of time. Time is also in equal intervals. That is, the difference will be 10, 1 hour, 2 hour, 3 hour, 4 hour. The difference is 1 hour, 1 hour. In that case, we can say that the object is in uniform motion. Here, one more thing we have to know, that is, in position, the position time graph for an object in uniform motion is a straight line. The position time graph for an uniform motion is a straight line. But here the difference is it is inclined, it is bent. The inclination of a line, the bending of the line, the inclination of a line, or the angle of inclination. The angle of inclination of the line is the angle which a straight line makes with the positive direction of x-axis, measured in the anti-clockwise direction. This inclination line is a straight line which makes with the positive direction of x-axis, because if the line is here, it is moving upwards. When compared to this horizontal, this straight line goes up and it makes some angle. Here, if the inclination increases with increasing angle, thus the mathematicians thought that as the angle increases, value of tan theta increases. In last graphs video, we already discussed that slope is nothing but it's a number which gives both the direction and steepness of the line. Here the slope is nothing but tan theta, means if the inclination increases with increasing angle, thus the mathematicians thought that as the angle increases, value of tan theta increases. If you see here, this is the line which is inclined, which is bent when compared to horizontal line. Here the angle increases. Means the value of tan theta increases, means the slope increases. So tan theta is the apt function for getting the slope of the line. Tan theta is the apt function. Tan theta of the angle is the ratio of the length of the vertical side to the length of the horizontal side. It is same as the rise to the run as the slope of the line. Slope formula. Slope is equal to rise by run. Means change in, which is also nothing but tan theta, change in y direction by change in x-axis. Change in y-axis, change in x-axis, which is also nothing but tan theta. Means here tan theta, we already know that in trigonometry tan theta is nothing but length of the opposite side by length of the adjacent side. Here the opposite side means which is opposite to the angle. That is why we are taking this as an opposite side. Tan theta is nothing but the vertical distance, length of the vertical distance by length of the horizontal distance. So the slope of any inclined plane, the slope of the which is here and it goes up, So how much the slope will, how much that inclination will, how much that bending will, we can say that by using the slope formula. Here it makes an angle. In this case, this uniform motion in position time graph will give the velocity. Velocity means we already know that change in displacement by time, means how fast it is changing. We can get through these graphs by this slope. Here one more thing you have to note, that if any lines intersect each other, their vertically opposite angles are equal. In this case, the slope of a line is positive if it makes an acute angle in the anti-clockwise direction. If this is the inclined plane, straight line with x-axis, we are measuring angles in anti-clockwise, we can say that that angle is positive. If we are measuring in clockwise direction, we have to take it as negative angle. Here these are also two intersecting lines. Here at the point of intersection, the vertically opposite angles are equal. If you see in this example, here the slope of the line, if we take the slope, that is vertical change and horizontal change, if we take, the slope of a line is positive. if it makes an acute angle, in the anti-clockwise direction with x-axis, if we take slope here, it will give theta. If we extend this line, same angle will do with x-axis, that means if we take slope in this graph, here it is angle theta. Same angle will do with x-axis. If we extend this line, same angle we can get. That is why we are saying that in this case, the slope of a line is positive if it makes an acute angle. Acute means that angles are less than 90 degrees. It may be 30 degrees, 20 degrees, 50 degrees, up to 90 degrees. If the slope of a line is positive, it makes an acute angle in the anti-clockwise direction with x-axis. The slope of a line is positive. If we take here, this is a convention. If theta is 45 degrees, here we are measuring in anti-clockwise direction. Theta is 45 degrees, tan theta is equal to 1, which is nothing but slope. And if inclination is 135 degrees, then it may be it will also minus 45 degrees in clockwise measure. In anti-clockwise measure, it is 135 degrees. In this case, the slope of the line is negative. If it makes an obtuse angle means it is greater than 90 degrees. Obtuse angle in anti-clockwise direction with the x-axis, or we can say that it makes an acute angle in the clockwise direction with the x-axis. Both are same. If it makes 135 degrees angle, obtuse angle in anti-clockwise direction, or it makes in clockwise direction minus 45 degrees with x-axis. In both the cases, we can say that the slope is negative. According to this, if we see this graph, in this we will get the change in vertical position and horizontal position. We can say that this is rise and this is run. In this case, the change in vertical direction and change in horizontal direction is nothing but slope. It may be x2 minus x1 by t2 minus t1. Here tan theta or slope is equal to QR by PR. Slope is nothing but, here we are taking position and time graph. That is why change in position is nothing but displacement, and change in time is change in time. So displacement by time, change in displacement is nothing but, with respect to time, is nothing but velocity. Means how fast the object is moving, which is nothing but the velocity. From this graph, we can say get the answer how fast the object is moving. That is nothing but velocity. In all these cases, we measured the slope for all these two conditions. Next, third condition I will explain in next video. I think it is clear for you. Thanks for watching.